Okay, so we're going to talk about how to determine whether a domain is discrete or continuous, or also how to graph that discrete or continuous data. So, the two differences here: a discrete domain is a set of input values, which again we talked about. Input is always x, right? Or the x-axis anyway. That consists only of certain numbers in an interval, so like integers 1 to 5. So in this situation, we have 1, 2, 3, 4, 5. We do not have anything in between. We are not representing anything in between. So our domain for a discrete domain is 1, 2, 3, 4, and 5. Pretty simple, right? We've been doing discrete domains for the past, actually, couple days. So when we find that domain, it's just the numbers, 1, 2, 3, 4, 5. That is what a discrete domain is. That's what we've been working with. However, now, a continuous domain is a set of input values that consists of all numbers in an interval. So that means from 1 to 5. And we've been representing this, actually, the entire last chapter when we were talking about compound inequalities. Here, we are representing anything in between and including 1 through 5. So in this situation, it'd be like 0.1, 0.2, all the way to 5. So we can represent our domain as a compound inequality, which we have done before. Again, put your lowest number, which is 1, here. We see we have a closed circle. That tells us it is less than or equal to. We'll use x, and less than or equal to again. Put our highest value here. So that's how you represent a continuous domain, because a continuous domain is anything in between these numbers. So something that can be represented by a discrete domain is, let's say you're buying tickets to a movie. When you go up to the counter and buy a ticket to a movie, you do not say, "Can I have half of a ticket, please?" They're not going to say, "Oh yeah, you can just sit in half the movie." No, they're not. So you're going to say, "Can I have 1 or 2 or 5 tickets to a movie?" That is a discrete domain. It's something that cannot be broken in half. It has to be represented by a whole number. A continuous domain is, for example, maybe you go to a gas station like Casey's in Nebraska, right? You say, "I want 1 piece of pizza. I don't want a whole pizza. I want 1 piece of pizza, which is 1/8 of a pizza," right? So you can buy a fraction of something. Or like eating a, let's say, a granola bar. You can eat part of a granola bar and still obtain calories, right? Here, you cannot break something in half. Here, you can. Those are the two differences. Discrete is whole numbers. Continuous is all numbers between two values, right? Okay. So that's the difference right there. Now, there's another way you can write a continuous domain as well. For example, if we had a number line, let's say this is 0, 1, 2, and this is -1 and -2. And we had a closed circle on -1, and we were pointing it all the way to the right. We do not have an endpoint, right? This is still continuous because we are still representing things in between -1 and on, all the way to infinity, but we don't have an endpoint, which means we could represent this, which is still a continuous domain, as a domain that looks more like this. X is greater than or equal to a -1. That tells us, including a -1, everything to the right is going to be a solution to that. So, again, these two we've talked about before. We just haven't talked about it in a continuous domain. That make sense? Okay. We're going to move on. So now we're going to talk about graphing discrete data. Again, we've talked about it. Discrete data is data that has to be represented by whole numbers. So in this situation, the linear function y equals 15.95x represents the cost, which is y in dollars of tickets for a museum. Each customer can buy a maximum of 4 tickets. First of all, we already know there's a maximum, and that's 4. And we talked about this already. You're not going to walk into a movie theater and ask to buy half a ticket, right? Now, I know you can split 1 in half with your friend, but you still have to buy 1 full ticket. This is the same thing. Tickets to a museum. You cannot buy half a ticket. So we already know this is going to be discrete. So the domain is discrete. Your explanation can be cannot buy half a ticket. Okay, we also know that the maximum is 4 tickets. So our domain in this situation, we can possibly buy 0 tickets. We can also buy 1, 2, 3, or even 4 tickets, but 4 is where we have to end because that's the most tickets we can buy. Okay, also our domain is going to represent our input, and we know here x is our input because we want to get our output, which is y, and x is tickets. So you can also say that your domain is represented by tickets. So those are the 3 things I want. I want your domain, which is tickets. I want to know if it's continuous or discrete. And I want to know what your domain value actually is. So we know it's 0, 1, 2, 3, 4. Okay, here, we know our input, which is also our domain, which is also our independent variable, is our tickets. So let's just say this is tickets. That way we don't get lost here. We know our output is money. So that tells us already what we're going to represent our graph with. Our x-axis is going to be tickets, our y-axis is going to be money. So all we have to do to find what we're going to pay for all 4 tickets is plug it in to our input and our equation. Our equation again was y equals 15.95x. Here we have 15.95x. So for 0 tickets, all we got to do is plug it in. 15.95 times 0, which is 0. Our coordinates now for our graph are going to come from our x and our y values. Our x was 0, and it made our y 0. So our coordinates are 0, 0. Okay, next, when we're going to buy 1 ticket, let's put it back into the equation again. 15.95 times 1. When our x is 1, our y is 15.95 times 1 is 15.95. So our coordinates are 1 for our x and 15.95 for our y. Again, we're going to use 2 as our input because we're buying 2 tickets. All we have to do is take 15.95 times 2. 15.95 times 2 is, I believe, 31.90. 2, 31.9. Okay, 3 and 4. Go ahead and pause this video, find 3 and 4. Let me know what you get. Okay, when we plug 3 in, we have 15.95 times 3. What do we get? We get 47.85. So, when our x is 3, our y is 47.85. So, 3, 47.85. Okay, and finally, let's do our 4th one. 15.95 times 4 is going to be what? 63.80. So when our x is 4, our y is 63.80. Okay, we have all of our values. We know tickets was our domain. And we know we could buy up to 4 tickets. We could also choose to buy 0 tickets, right? Now all we have to do is graph it. So I'm going to scroll down, and I'm going to graph. So remember, our x-axis is represented by our domain or our input. Our input was tickets. We bought 0 to 4 tickets. So let's put 0 here. Let's skip one, give ourselves some room. 1, 2, 3, and 4. We know this is tickets. Make sure you label your axes so that way I can tell what you are trying to say. Your y-axis is your output, and your output is represented by money. Money. Okay. Now, we go from $0 to $63.80. What I would do is I'd probably go up by 5s. So what I'm going to do here is I'm going to say this is 5, I'm going to say this is 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, so the top bar is 60. We do have a little bit left up top, so that's going to work out just fine. Okay, at 0 tickets, we paid $0. So that's where we're going to make our point. Buying 1 ticket costed us $15.95. So let's say it's about there. Remember, this is a linear function, so we're going to try to make this line as straight as we can. Okay, if we buy 2 tickets, we spend $30.90. So let's find $30 or $31.90. So right around there, I'd say. If we buy 3 tickets, we're spending $47.85. So let's go to 3 tickets, and let's go all the way up to $47.85. And now 4 tickets, $63.80. So at 4 tickets, we spent $63.80. Let's go to the very top of the graph. Now, typically, I know that you guys are used to, oh, I want to connect these dots, but this is discrete. You cannot buy half a ticket, so we are not including any of the information in between the dots, right? So we do not connect the dots. We are just saying that at $0 you spend 0, or at 0 tickets you spend $0, 1 ticket you spend 15, all the way up to 4. We cannot represent anything in between these because it is discrete. We cannot buy half of a ticket. We are done right there. So let's move on. Okay, this is a monitoring progress. The table's already set up for you. The table's not always going to be set up for you. You don't always have to use the table. If you just want to multiply it all in your head and figure out what the 4 values are going to be, go ahead. That's up to you. So go ahead and pause the video. Try to do the monitoring progress, see if you get it right. Okay, let's go over it. The linear function m equals 50 minus 9d represents the amount in m, which is dollars, of money you have when you're buying DVDs. Find the domain of the function. Is the domain discrete or continuous? And graph the function. So we got to do 3 things, right? So the first thing, let's find the domain of the function. Remember, your domain is typically always your input. Remember, when we look at this equation, our input is what we're plugging into the equation to get our output, which is our end result. So our input's represented by D. Now, what's represented by D? DVDs. So DVDs is our domain. DVDs. Okay? Now, we need to figure out how many DVDs we can buy. And we can figure that out by plugging 0, 1, 2, 3, 4, and maybe even 5 in for DVDs. So I'm not going to write my domain until I can figure out how much money I have left after the 4th, because if we can include a 5th DVD, I want that in my domain. I want every possible value within my domain. So let's start here. We have 50 minus 9 times 0. 9 times 0 is 0. 50 minus 0 is 50. So when x is 0, y is 50. So 0, 50. Okay, same thing goes for 1. 50 minus 9 times 1. So 9 times 1 is 9. 50 minus 9 is 41. So when x is 1, y is 41. Okay? We're going to do 2 now. Find 2 DVDs. 50 minus 9 times 2. What's 9 times 2? 9 times 2 is 18. 50 minus 18 is 32. So when x is 2, y is 32. Okay, 3. 50 minus 9 times 3. 9 times 3 is 27. 50 minus 27 is 23. So when x is 3, y is 23. Okay? And 4. 50 minus 9 times 4. 9 times 4 is 36. 50 minus 36 is 14. So when x is 4, y is 14. Okay, we've learned some things from this. First of all, our domain is going to be discrete because you can't break a DVD in half and sell it to somebody. I mean, you could, but you'd be a real jerk because they're not going to be able to use it, right? So we know it's discrete. Okay. Second of all, we noticed we started with $50. After we bought one DVD, we had 41 left. That means each DVD costs $9. That tells us when we have $14 left, can we buy a fifth DVD if DVDs cost $9? Well, yes, we can. So the domain I want you to write actually is going to include that fifth DVD. So we have 0, 1, 2, 3, 4, and 5. Now, once we would buy that fifth DVD, we would not have enough to buy a sixth. That's why we're going to stop at 5. Now let's graph it. Again, our domain, which is always our x value, is our input when our input was DVD, so our x-axis is DVDs. That means our y-axis has to be the dollars we spend, so it's money. Okay. DVDs. We went from 0 to 4. I know that we didn't go to 5. I'm not going to make you put 5 on the graph, but I do want that 5 in your domain. So we have 0, 1, 2, 3, and 4. And money, we started at 50, ended at 14. So let's go by tens again. 10, 20, 30, 40, 50. And again, I want to leave that space in between so that way I know that one's 5, especially when it's from 50 to 0. Don't forget to include your 0 at the bottom as well. So, when we bought 0 DVDs, we started at $50. So the first point was up here. When we bought one DVD, it went down to $41. When we bought 2 DVDs, it went down to $32. When we bought 3 DVDs, our value dropped down, or our money dropped down to $23. And when we bought 4 DVDs, our money dropped down to $14. You notice, that's as straight as a line as we're probably going to get, because it's a linear function. Okay. Do we have to connect these dots? No, we don't. We don't connect these dots because you cannot buy half a DVD. Remember, if you have any questions, please ask me during class. Let's move on. Today we're going to graph some continuous domains now. Continuous data. Let's start up here and let's answer these questions. Does the situation represent a linear function? Well, let's see. A cereal bar contains 130 calories. The number of C calories consumed is a function of the number of B bars eaten. So, we know it's a function. We just need to know if it's linear or nonlinear. Well, as we talked about earlier, if we can put it in the form y equals mx plus b, then it is a linear function, right? So, when we look at this, we see we have calories consumed, and we see we have bars eaten. We're really trying to figure out what the number of C calories consumed is, so that's our output. Okay. The number B is bars eaten. We don't know how many bars we're going to eat, but we know each bar is 130 calories. That's our equation. Now, if I were to change this C to a Y and this B to an X, so if I have Y equals 130X, that looks a heck of a lot like Y equals mx plus b. We know it is a linear function. So, yes, and this is our explanation. That's all you need to do. You need to write the equation and put yes or no. Now, I'll give you a little hint. In Algebra 1, we're probably not going to be doing a whole lot of nonlinear functions, so typically it's always going to be linear. You just have to be able to write the equation. Okay, we have to find the domain of the function. Is the domain discrete or continuous? Okay. The domain is going to be our input, which is bars, right? So the domain is bars. Is this discrete or continuous? Well, the question I have is, Can you eat half of a granola bar and still gain calories from it? Yes, you can. So it is continuous. Okay. I want that domain written in numbers, but I think it's a good idea to probably wait until you graph it to write that domain. That's just my opinion. So we have our equation. We know it's linear. We know our domain is going to represent bars. We know our domain is continuous. We just don't quite know what our actual domain is yet. So let's graph it, let's solve it, and we'll find all that out. Okay, again, our equation was C equals 130 B. One thing I want to point out is up there it talked about how calories is a function of. It's probably going to be what our output is every single time. A lot of times you'll see it written like this. You'll see that f of c, because it's the function of c, equals 130 b. And that's why the c always goes there. Okay. Our input is the number of bars we're going to eat. Our output is c. This is only a 3-column table. You can represent it in a 3-column table. You can represent it in a 4 or a 5. That's completely up to you. You don't always have to use a table either. So I'm going to make this easy on myself. I know that continuous domains, I can eat fractions of a bar, but I like whole numbers. I'm going to use 1, 0, 1, 2, and 3. So if I plug 0 in for B, if I use 0 bars, I'm going to probably ingest 0 calories. 130 times 0 is 0. When our x is 0, our y is 0. So 0, 0. Okay. 1, if I eat 1 bar, 130 times 1 is 130. When I eat 1 bar, I'm going to have 130 calories. When my x is 1, my y is 130. Okay, when I eat 2 bars, 130 times 2, that's 260. When my x is 2, my y is 260. Okay, and 3. 130 times 3 is 390. When my x is 3, my y is 390. So those are our coordinates. Now, could we keep going? Yeah, we could. But there's no maximum, so we don't have to keep going. The thing that I'm going to make you do is I'm going to make you at least have 4 values so we can have 4 dots on the graph. If we have a maximum, I want you to find that maximum, but it doesn't give us a limit on the bars we can eat, right? So let's just graph it. If it said up to 6 candy bars, we would have to go all the way to 6 because I need to know what it's going to end at, right? So we start here. We know our x-axis is going to represent our input or our domain, which is bars. Remember, they are all connected. Our x is our domain. It's also our input, right? That's why it's our x-axis. Our y is our output. It's also our range, which is our y-axis, and that is calories. We know it's continuous. Go ahead and circle continuous. Okay. Now we ate 0, 1, 2, and 3 bars. Okay, and we went from 0 to 390 calories. I think we should just probably go up by 100. Okay, at 0 bars eaten, we had 0 calories. So our first dot goes on 0, 0. At 1 bar eaten, we had 130 calories. So let's go to 1, go up to 130. At 2 bars eaten, we went up to 260. So from 2 to 260. And at 3 bars eaten, we went from 3 to 390. Okay, so after we graph, we know that it's continuous, so we know we're going to connect our dots. But did it give us a maximum? If it gave us a maximum, then we would stop at the maximum, but it didn't. It pretty much just says, you know, you get how many calories for each bar you've eaten. So if you want to eat 100,000 bars, you can. So in this situation, we connect all of our dots, and it goes on forever because there's no maximum. So instead of our domain being a compound inequality like we talked about earlier, our domain is going to be x, and we see we start at 0, so let's put our 0 here. And since our line's going up, our x is going to be greater than or equal to 0. So write it a little bigger for you. D equals x greater than or equal to 0. Now, if you have a maximum, like I said, you're going to write a compound inequality, but you don't. So we're going to write just an inequality that represents something that goes on forever and ever and ever. Okay. So monitoring progress. We'll go over this one. So this is kind of up in the air. I'm not going to put one like this on your test. But number of stories and height of a building. X is the number of stories. That's going to be our domain. Is it discrete or continuous? I'm going to say it's discrete, because technically you're not supposed to build half a story. I know some buildings do have half a story, but we're going to leave it at that. Okay. This down here is going to be your homework. So a 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number of G gallons remaining is a function of the number M minutes. Does this situation represent a linear function? Explain. Find the domain of the function. Is it discrete or continuous? Then graph. You can write a table if you want. If you want to write a table, kind of look at what we just did. Write a table that way. If you don't want to write a table and just use the equation over and over and over again, you don't have to. But I'll help you. I'll write the equation, but this is going to be your homework. The rest of this is going to be your homework. So, does the situation represent a linear function, yes or no? Well, let's see. A 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number of G gallons remaining is a function of the number of M minutes. So, does it represent a linear function? Well, we know that G is a function, right? So G equals, it's also typically written as the function of G equals, now it's going to be 20. We start at 20. And draining means we're losing water, so we're going to do a subtraction. And 2.5 gallons per minute. So an M for minutes. Okay, now, we know it's continuous because it already tells us 2.5. You can lose half a gallon in however many minutes. So, we know it's continuous. Okay? Now, it's your job to find the equation, find what our graph's going to look like, and we need to think about this. We start at 20 gallons, and we're losing 2.5 gallons per minute. Eventually, that bathtub's going to be empty, right? So we are going to have a max. So, find where that endpoint is, and your domain is going to look like your starting number with your, I'll put a G here, or no, I'll put an M here for a minute, with your two inequality signs and your ending number here. Find the endpoint, because we know there's going to be one, and write your domain like this. We will talk about this and go over this tomorrow. But again, try to do all this on your own. And if you can't, like I said, we'll talk about it tomorrow. Thanks.